Uh, Good morning, students. In last class, we discussed the solution of non-homogeneous partial differential equations by direct integrations. Now, let us discuss the new type of example is that solution of homogeneous partial differential equations involving derivatives with respect to one independent variable only. In last class, we discussed that the solution of non-homogeneous differential equations by direct integration. In that particular example, we had two independent variables. Now now you are discussing an examples of having only one dependent variables. Okay, so what you have to do is that you just go through this note what I have given here, and I will explain totally in the example that how to solve this type of examples when it is given in only one variable. Now you observe here, the first example is that solve dou square z upon dou x square plus z is equal to 0. Given that when x is equal to 0, z is equal to e raised to y and dou z upon dou x is equal to 1. That means these are the conditions is given. Now you observe the first this homogeneous differential equation. You observe here having only one variable, and you go through the previous method of example is that you are having here two types of independent variable. Okay, z is a function of x here. Now you let us see here that z is a function of x only one variable is there. Then how to do this type of example is that the given different partial differential equation assume form of the ODE. If it is having one variable, you can assume this partial into ODE. ODE means what? Just you replace d dou by d. You have write down here ordinary. Okay, so dou square z upon that is d square z upon dx square plus z is equal to 0. It looks like the ordinary differential equation. You know how to calculate ordinary differential equation solution. You can write this in the form of d square plus 1 of z is equal to 0. Auxiliary equation is given as, this auxiliary equation, you calculate the roots of this here. Then the solution of ODE is given by z is equal to c1 cos x plus c2 sin x. By using these roots, you can write the solution like this. After the solution, now you observe here, the solution of PDE is got by. Now what you have to do is that you have to replace C1 and C2 by which is not given here, independent variable, that you have to take as a constant. What is independent is not given. You have to replace C1 by f of y. Y is not given. Plus C2 is replaced by g of y, where y is a constant. Are you clear? Where y is a constant, because you did the example of z is a function of x where y is become a constant. So therefore you have to take that type of constants here. Now this is your solution called as 1. Now your aim is to calculate f of y and g of y. To calculate f of y and g of y, the conditions are given. The conditions are x is equal to 0, z is equal to e raised to y. This is one condition. Then another condition is that x is equal to 0 and dou z upon dou x is equal to 1. Now let us use the first condition, and the second condition is for the next. I will tell you, x is equal to 0 and z is equal to e raised to y. That can be written like this. Use the condition to calculate f of y and g of y. When x is equal to 0, z is equal to e raised to y. Substitute these two values in above equation. Okay, substitute z is equal to 0. If you substitute, z is equal to e raised to y, that is f of y cos 0 plus g of y sin 0. You know that sin 0 is become a 0, so this is 0. So f of y cos 0 is 1, so f of y is equal to e raised to y. Keep it as it is. Now what you have to do, that you have to use the other condition. The other condition says that dou z upon dou x is equal to 1 when x is equal to 0. So dou z upon dou x, where it is having, we don't have any dou z upon dou x here. So what you have to do, that you have to differentiate this z with respect to x, keeping y as constant. You will get dou z upon dou x. Okay, so differentiate, you will get like this. Okay, after differentiating this, use these conditions. X is equal to 0, dou z upon dou x is equal to 1. Use these conditions. So therefore applying these conditions, you will get this type, g of y is equal to 1. So after getting the g of y, f of y, put in equation 1. If you substitute this one, you will get this, z is equal to e raised to y into cos x plus sin x, which is a required solution of this partial differential equations. Okay, now let us go for another one example, which is very example. This is from the question paper. This is QP. This is from question paper. Okay, same example is there. Okay, dou square z upon dou y square. Here z is a y is a function of z. Sorry, z is a function of y. So you go through this example. Okay, so after solving, let us assume this z, this partial differential equation to ordinary differential equation, the ordinary differential equation. Then you know how to calculate the auxiliary differential equation. Okay, that you got the roots here. Then the solution of the ODE is given by z is equal to this one, and c1 and c2 is replaced. Now you observe e raised to y is there, y and z is there, x is not there, so you have to take x is a constant. So c1 is replaced by f of x, c2 is replaced by f of g of x. Okay, replacing, called as equation. Now your aim is to calculate f of x and g of x. To find this f of x and g of x, use the conditions. Now you observe here, condition what is given: y is equal to 0, z is equal to e raised to x. This is one condition. Y is equal to 0 and dou z upon dou y is equal to e raised to minus x. Now let us use first condition. Using the first condition in this equation, the equation become like this. Keep it as it is. If you want to call it as, you can call it as here, equation number 2. Okay, then after this, again you differentiate this z with respect to x, sorry, with respect to y, because you want here dou z upon dou y. So therefore differentiate this z, so it becomes with respect to y, it becomes dou z upon dou y is equal to f of x as it is, e raised to y differentiation, e raised to y, minus g of x, e raised to minus y differentiation is e minus e raised to minus y. Now again using the conditions are this one. We use these conditions, the answer becomes like this. And if you want to call it as, you can call it as equation number 3. Solving equation 2 and equation 3, if you add one time, you will get f of x. If you subtract one times, you will get that is g of x. Okay, adding means add this one, cancel this one, 2fx e raised to x plus e raised to minus x, transfer this to here, e raised to x plus e raised to minus x divided by 2. This is known as cos hyperbolic x. Similarly, for g of x is sin hyperbolic x. Use these conditions in equation 1. Equation 1 is your solution. Okay, f of x and g of x, substitute f of x, g of x. If we substitute f of x and g of x, the answer becomes z is equal to cos hyperbolic x e raised to y plus sin hyperbolic x e raised to minus y, is which is a required solution. Okay, so you go through this next example, you get to know. Okay, thank you. After this we will go for the solution of the PDE by Lagrange's method is that. So let us discuss in the next class. Okay, thank you.